entropy. So the symbol for free energy is capital G. That is in honor, the symbol for free energy is G. It is in honor of American scientist Josiah Gibbs. That is why we call it Gibbs free energy. Gibbs free energy, 1839 to 1903, who made many contributions to thermodynamics. The change in Gibbs free energy is equal to the change in enthalpy minus the mathematical product of the change in entropy by the Kelvin temperature. Remember, this temperature must be in Kelvin. So if in any calculation, if the temperature is given to you in Celsius, before you use it, you have to convert it to Kelvin. Each thermodynamic quantity in the equation is for substances in their standard state. The usual unit for change in enthalpy is kilojoule per mole, while entropy change is often reported as in joule per Kelvin per mole. So it is necessary to change the unit for change in entropy to kilojoule per mole, so that kilojoule per Kelvin per mole. You cannot work with two different units. So before you use your entropy, look at the unit. So if the unit is in joule per Kelvin, you have to convert it to kilojoule. Just convert the joule there to kilojoule, so that the calculation of your Gibbs free energy will be in kilojoule per mole. Now we say a spontaneous reaction is one that releases free energy, and so the sign of delta G, that is your change in Gibbs free energy, must be negative. It must be negative for a reaction. If you want to use, we said for spontaneous reaction, your enthalpy must be negative, your entropy must be positive. So also your Gibbs free energy must also be negative. That is another sign for spontaneous reaction. Enthalpy negative, entropy positive, Gibbs free energy negative. Since both change in enthalpy and change in entropy can either be positive or negative depending on the characteristics of the particular reaction, there are 4 different general outcomes for delta G. Now let's look at this outcome in the table we have in the next slide. Okay, now let's look at it here. We have the first one, change in enthalpy, then we have change in entropy, and then we have the Gibbs free energy. So if in the particular reaction now, the first one, if change in enthalpy is exothermic, that is negative, and then the entropy is positive, that means there is high disorder, then your delta G will be negative. When you have negative enthalpy, positive entropy, then your change in Gibbs free energy will be negative. Then if you have your entropy to be positive and your enthalpy is also positive enthalpy, positive entropy, then your change in Gibbs free energy will be negative at higher temperature. If you have both as negative, then your change in Gibbs energy will be negative at lower temperature. Take note, positive, change in Gibbs free energy will be negative at high temperature. If it is negative, Gibbs free energy will still be negative but at lower temperature. But if you have your enthalpy now as positive and then your entropy is negative, then your Gibbs free energy can never be negative, and then such reaction will not be spontaneous. So study this table very, very well. very well and get the interpretation so that you can apply it when required. Now keep in mind that the temperature in the gives free energy equation is the Kelvin temperature, and so can only be positive when delta H is negative and delta S is positive. The sign of gives free energy will always be negative. I told you the other time, it's even in that table. Once you have your enthalpy as negative and you have your entropy as positive, your gives free energy will be negative and the reaction will be spontaneous. So at all temperature, this corresponds to both driving forces being in favor of product formation. Yes, so for a product formation to be favored, the enthalpy must be negative, entropy must be positive, gives free energy must be negative. When delta H is positive, that's your enthalpy, and delta S, your entropy, is negative, then the sign of delta G will always be positive. That is the last row you have in the table. So since it is enthalpy that is positive and entropy is negative, then your gives free energy will be positive, and that will make the reaction to be non-spontaneous. So this corresponds to both driving force working against product formation. So the product formation will not be favored, and then that will give a non-spontaneous reaction. So I want you to really study this table and then this explanation here, so that at any point in time you will know, question can come in any form. So once you understand that table and you know conditions that can make a reaction to be spontaneous, then you should also know conditions that can make a reaction to be non-spontaneous. A spontaneous reaction will favor product formation, while a non-spontaneous reaction will not favor product formation. So take note. When one driving force favors the reaction but the other does not, it is the temperature that determines the sign of this. That is why that is where you have the two middle lines in that table. So you can see that the determinant will now be the gives free energy. So either the gives free energy will now say, okay, maybe I should be negative at high temperature, or I will be negative at low temperature. So consider first an endothermic reaction. An endothermic reaction, enthalpy will be positive, and then entropy, an increase in entropy, which is also positive. Both of them are positive. Remember from the table, what will happen to your gives free energy? It will be negative at high temperature. But if both of them are negative, that is, your enthalpy is negative and your entropy is negative, then what you will have there will be negative gives free energy but at low temperature. So therefore, as temperature increases, the multiplication of temperature and entropy change terms in the gives free energy equation will begin to predominate, and then your delta G will become negative. A common example of a process which falls into this category is the melting of ice. At a relatively low temperature below 273 Kelvin, the melting is not spontaneous because the positive delta H term outweighs the T temperature and the change in entropy term. So when the temperature rises above 273, then the process becomes spontaneous because the temperature, larger T value, has tipped the sign of Hg over to being negative. Okay, so when the reaction is exothermic but undergoes a decrease in entropy, it is the enthalpy term that favors the reaction.